All right, so for a warm-up, it says, is negative 9 a solution of a plus 7 equals negative 2? So when they tell us that negative 9, let's see if that was the solution. So I know I'm substituting that negative 9 in for a. So the question is negative 9 a solution to that equation? What do you think?
Yeah.
Yes.
Yeah.
You should have shown your work, and you would put in negative 9 plus 7 equals negative 2. And negative 9 plus 7 is negative 2. Because they come out to a true statement, you simply will say yes. On number 2, solving the equation. H plus 12 equals negative 8. And you put your laptop away so you're doing notes with us. Do what? From Schoology? Do you know how to do that still? Oh, if you know how, you can. H plus 12 equals negative 8. We just have to solve the equation. So what would I go ahead and do? What do you think would be our first step? All right, Joshua.
Get H by itself.
Good. Since we don't know what our variable is, but we want to get the variable by itself. So it's H plus 12. So we subtract 12 from both sides of our equal sign. H equals negative 20. And that kind of looks like a beat. That was horrible. H. So H equals negative 20. Last one that we're going to look at is finding X and Y intercepts. This was a review from last semester. They gave us the equation 5x plus 3y equals 15. How do I find the X intercept? I want to remember, that's where our line crosses the x-axis. So how do I find that, Brianna?
Change y to 0.
Perfect. When you have an x-axis or intercept, and it's going to cross our x-axis, that means my coordinates for it, x can be a number, but y has to be a 0. So I solve this. I say 5x plus 3 times 0 equals 15. 3 times 0 is 0. So I'm left with just 5x equals 15. And if I divide by 5, x equals 3. So my x-intercept is at 3, 0. What about my y-intercept? Okay. No, we don't want to put the 3 in. That'd be if we're solving the equation. Joshua?
You want to turn, you want to turn X.
Yeah. So for y-intercept, remember the coordinates for y-intercept, the x-coordinate is 0. And just think of our little grid here. If I do my y-intercepts here, that means it did not go left or right. My x was a 0. It did not move off there. So I'm going to just solve this where 5 times 0 plus 3y equals 15. We're left with 3y equals 15. Y equals 5. So our x-intercept is at 3, 0. Our y-intercept is at 0, 5. All right. Today what we are going to begin working on is we are going to say I can solve and graph inequalities using addition and subtraction. Today we're going to start with an easy one, just addition and subtraction. But my first question is, what is an inequality? Brandon? Maybe. What was different from inequalities than our other equations? Aiden?
Aren't those like the equations like greater than and less than?
Yes. Inequalities are going to be the ones that we go ahead and say less than greater than, less than or equal to, greater than or equal to. Mainly, our answer can have multiple answers. It's not going to be one set number. When we said something equals another one, it's one number equals something else. When we say it's greater than, if I say x is greater than 5, well, I can choose any number that's bigger than 5. 7, 56, 892. So we're going to show how we're going to graph those. In previous lessons, we focused on linear equations. By the end of chapter 6, by the end of this whole unit, you will be able to write and graph linear inequalities as well as absolute value equations and inequalities. I will give you a little heads up. The absolute one is where it kind of tricked up some people in my last class with algebra. But inequalities should not be too much different than what we've worked with before. So, this is where I want you to have your orange foldable out ahead of you. Okay, if you have your foldable in front of you, everything I'm going to do right here, I'm going to do with you on the orange foldable. That's why Derek let me use his. So, here's my foldable. And what we're going to go ahead and do, we'll fill this out, and then I'll show you how you're going to put it in your binder, your notebook, for our notes that we can go back and reflect to. The first thing it says, the meaning says less than. So less than means m less than -2. We're going to write this in there. This is our less than symbol right here. Remember, in math, we read left to right. So the number from the left, the sign for less than, if you ever think of the Pac-Man, the mouth's open away from it. An example sentence we would write is m is less than 2. Okay, now when I ask you to graph this, so this is our equation. We're done. This is simplified. This is as small as we can go. M, whatever the variable m stands for, that has to be less than -2. If we think of possible solutions, what could be a possible answer for m?
-4.
-4.
Oh, -6,026.
-6,026. Good. Any of those. When we graph it, we're going to use a line graph to show it. And to do so, I'm going to say, okay, well, there's -2 here. So I'm going to put 0 right here in the middle on this tick mark. And you can kind of change your line to be your number line any way you want. Here is the important thing. You have to put this in the right order. Our numbers to the left are our negative numbers. To the right is our positives. Now, this is the important part. Since I have m is less than -2, and I'm comparing it to -2, I'm going to mark where -2 is. So I'm going to put a circle right here on -2. And do not shade it in. We do not shade it in because that tells me as a mathematician looking at this that this is a less than. It's not less than or equal to. Now, the last part we have to do is we have to say, what are my possible answers? Well, if m has to be less than -2, I'm just going to draw my line this way. And we draw our line facing this way. When we have graphed this now, as a mathematician, I can look at this graph right here, and I can say, okay, they're comparing to -2 and it's open, and it's getting smaller. All the answers are anything over here is the answer. If I went to the left, that means it's less than. So I know it's n is less than -2. And I know it's only less than because I did not shade that circle in. On the next example, you're going to see this a little bit different. It says less than or equal to. So when we have it less than or equal to, let's use the letter P. I'm going to say P is less than or equal to. Remember, you put that little line under your less than sign. That means it's either less than or it's equal to. And we'll just say 1. As a sentence, we say P is less than or equal to 1. Now, the time when we have to graph this. We graph it. I'm going to go ahead and make my number line still. 1, 2, 3. -1, -2, -3. So I have my number line. And we were comparing to the number 1. Because it is less than or equal to, though, you fill that dot in. And because it's less than, we move down to the left. I forget who it was in our algebra class that pointed out that the way they remember which way their arrow goes is like, I'm going to draw it on the board. Here's our less than sign. They just went, whoop. I didn't say that part. Someone showed me that, and that's when I showed it to you. So they said, it was either you or Lucas or something.
It was Lucas, because in first grade when we were learning that, I learned it.
So, the only difference between when you graph less than and less than or equal to is the important detail that you will have to make sure you're being accurate with. Less than, open dot. Less than or equal to, fill that dot in. So if we do that, you should be able to do the next two pretty simple. The next one says greater than. Well, we know our greater than sign is like that. So an example is S is greater than -1. I'm going to write that out as an example. S is greater than -1. Alright, so I'm going to pick on someone here. I'm going to make my number line 0, 1, 2, 3. Remember, our negatives are on the left, positives to the right. Our numbers get bigger to the right. Okay, so I'm going to pick on someone here. I can see that I'm comparing to -1. So when I make my point on that one, should I fill the dot in or should I leave it open? Ooh, a couple people got it. Alex, what do you think, bud? Yeah, we're going to leave it open because it's only greater than. This tells me that at -1, since it's open, the answer cannot be -1. It has to be, and this time my arrow is going to the right. It has to be greater than -1. R is greater than or equal to 0. Example, R is greater than or equal to 0. 0, 1, 2, 3, -1, -2, -3. I want you to go ahead and graph this one if you have that already. See if you guys did this right. Make sure on your number line that you're marking what your ticks are, or at least a couple of them. Alright, Henry, what kind of dot am I going to use? Open or closed?
Closed.
Closed dot, and where are we going to put it? On the 0. And it's greater than, we go this way. Okay, last one, and then we'll do some example works with this. See if we can apply what we're learning. Not equal to. And we have times where this happens. So I'm going to say n is not equal to 3. Meaning, hey, my answer can be anything. Give me any number except for 3. I do not want you to say the number 3. How do you think I would graph this? Let's think about this first. Would it be an open dot or a closed dot? Have to be open.
Yeah.
I like that you're thinking half and half. But it have to be open. Why could it not be a closed dot? Devlin?
Because if it was a closed dot, that would mean it can also be 3.
I mean, it could also be 3. So I'm going to make my number line. I'm going to move it over just a little since I know I'm using with 3. 1, 2, 3, 4. Okay? So I know it has to be an open dot. But now what do I do? Take about 30 seconds. Try and figure it out. Talk to your neighbor. See if you guys can come up with an answer.
Yeah, that's what I thought that. That's not.
Alright, let's come back together. What do you guys think? What did you come up with? Caitlin, what do you think, hon?
I think that the arrow should go on both sides.
Perfect. The arrow is going to go in either direction. My answer can be less than 3, or my answer can be greater than 3. Okay, so I'm going to put this is going to be part of your homework to do this. This is what I'm going to ask. This isn't for a grade. This is going to be to help you when you study for a test. But you're going to take this sheet and you're going to set it up in your notebook. You can come back to the video if you need help. But in your notebook, we should say chapter 6. You're going to say inequalities and inequalities of order matter, because we're doing 2 today. And so you'd have your chapter 6. And this is what this will look like. I've already done 1. you will take this paper and you'll end up folding it in half, but you cut along these dashed lines, just the dashed ones. These are solid. And you do it so it ends up like this. So if you have to go back and look at the video when you go to put it in, this will help you study. But your foldable will look like this in your notebook. So then when I say less than, I open it up, and there I see an example. I see greater than or equal to. There's how it works. Okay? I'm going to put that to the side. And let's go back into our OneNote.
Mr. Cecil?
Yeah.
So if it's supposed to be 3, like not going to be 3, less than or greater than, then what would the raise be for negative 3? Because it's technically 3, but it's the opposite.
Alright, so the importance of labeling. I want to make sure we are very clear on this. You should be on your OneNote still. Yeah, I'm going to make sure we're focusing so we can work. The importance of labeling your number line correctly is very, very important. How do I label a number line? You can take a positive number and just change the signs to negative. No. When we do this, it does not go 0, -1, -2, and go that way. You will always, number line should always go from the smallest to the largest, reading left to right. So this is a rule, so I stay consistent in math. -5. When we work to the right, our numbers are getting larger. So your negatives are going left, your positives are on the right. Okay, this is what you're going to be doing today. You're going to have to graph the inequalities just like we did. But the first thing is we have to solve the inequalities, which is not hard. Here I have f plus 5 is less than or equal to -7. So I have to get f by itself.
Wait, it's not like 7.
7.
You said -7.
Oh, I'm sorry, just 7. So f plus 5 is less than or equal to 7. We solve this by, we treat this inequality just like we did with an equal sign. They're balanced on both sides. So I'm going to -5, and you should be doing this with me. I'm -5 from each side, so now I have f is less than or equal to 7 minus 5, which is 2. I'm done. I have my variable on one side all alone. Now I graph it. So I take my graph, and I know I'm looking at a 2, and I'm saying less than 2. I can make my number line pretty much however I want. You can zoom in at any point. I'm just going to do 0 in the middle and go 1, 2, 3, -1, -2, -3. And because it was a 2, but my sign was less than or equal to, do I use an open or a closed dot? Closed. So I go to 2, and I use the closed dot, and I'm going less than. My arrow should be going to the left. I personally kind of see how I do mine, where my line comes up and then over, so it's off the number line. I do it that way so you can see it. If you want to do it on the number line, you just have to make sure you're shading in dark that we can easily tell where you're at. All right, so let's try B. I'm going to do this one with you, then I'll have you guys do a couple more. I'm going to go ahead and subtract 2 from each side. I'd have P is less than or equal to 1 minus 2, gives me -1. I'm done. P's all by itself. So now I'm going to go 0, 1, 2, 3, -1, -2, -3. Open or close dot. Close dot at -1. And since P is less than, we're going to the left. Go ahead. I'm going to pause the video. I want you guys to take just a couple minutes to do A and B for me. You work with the partner if need be. All right. Pay attention, folks. Back up here. Let's look at these two real quick. On A, we added 5 to both sides, and we should have got x is greater than positive 1.5. When I went ahead and did my graph on my number line, I still did it the same, 0, 1, 2, 3, or whatever. And then I just put my number in here, and I labeled what it was, 1.5. Remember, it's an open dot because it was greater than, and then it went to the right. Here's the part that I really wanted you to see, though, because I don't want us to get too caught up on number lines. They have to be the exact same. On B, when we added 9 to both sides, we were able to get x is less than or equal to 12. Well, I didn't want to go by 0 in the middle, 1, 2, because that would take a huge time to get to. So I just zoomed my number line in. I started at 2 on the left, and I counted by 2s. Sean, try to make sure you're focusing with me so you know how to do this today. So we have 2, 4, 6, 8, 10, 12, 14, 16. When I put this in, I'm looking at 12, and it's less than or greater than, so it means it's going to be a solid dot at 12. And it's less than, so I'm going left. Your number line can look different. The important thing that I need to see in your number line is that your dot is solid, and it's on 12, and then your arrow's pointing to the less numbers. Okay? A couple parts that we're going to go kind of quick with so you guys can finish up something. Write the inequality represented by this. Okay, we can do this. Now they did the graph, we have to write out the equation. So we can use any letter we want. We'll just use x. And I'm going to read it left to right. So I would say x. And now don't shout it out, but think. And raise your hand when you have the answer. Is my answer going to be less than or equal to? So do I want to say x is less than? Or am I going to say x is greater than? Devlin, what do you think?
It's going to be greater than, because it's going to the right.
Okay, it's going to the right, so I know it's greater than. Oops, and I drew less than, because why not? Now, is it greater than, or is it greater than or equal to? Okay. How do you know it's greater than and not greater than or equal to?
Because the circle is open.
Very good. Open dot means greater than. And what's it greater than? Someone said it. Devlin again?
Negative 6.5.
Negative 6.5. So B, we're going to do the same way. I'm reading left to right. So I'm going to say x. My arrow's going to the left. So that's telling me it is less than or greater than. Which one are we looking at?
Probably. You're doing like advertisements.
What do you think, Jackson? Is it going to be less than or greater than? Okay. Oh, boys and girls. We still have a couple things we have to finish up. It is less than. Now, is it less than or equal to? Good. Solid dot. And what number did we start with? We started with 4. So your answer is x is less than or equal to 4. Last three I want to do, and then we're going to stop because I want you to do a couple things. 1. The speed limit is 35 miles an hour. We have to write an equation for this. Write an equation. Now, if the speed limit's 35, can I go above 35? So what's, but not legally. So what sign do you think I'm going to have to use? I'm going to say my speed is X. If the speed limit's 35, what inequality sign should I use, Brianna?
Less than or equal to?
Why or equal to? Why not just less than?
Because the exact limit is 35, not anything below 35.
Good. I'm allowed to drive 35. So I can go right up and be on 35 and be driving that speed limit. So I have to say less than or equal to. Number 2. The sum, so sum means to the addition of 14 and m is greater than or equal to 5. So I'm just going to write this left to right. It's really not that difficult. The sum. So that means I'm going to be adding. And what numbers am I adding? 14 and m. So you would write 14 plus m is greater than or equal to 5. Okay, I'm going to stop there. I know we have one more, but we have 5 minutes left, and you have to do something before you leave. So, I'm going to go over a couple things. 1, your homework. Out of the textbook, page 359 to 361, 2 through 28 even, and then 32, 34, 40, 48, 50. Okay? Before you leave, oops, wrong thing. You have an exit ticket. So, you can go ahead and close your laptop, put your stuff away.
What's the
Put your name on this.
exit ticket?
If you ever see that, we're to give it a shoot.
Alright, before you leave, I need you to finish this. Do this by yourself. Not with the help of a neighbor or anyone else. It's that page 359, Come on, what's short?
Just don't take it.
Because I am short. I would have to do it.
Oh, you're just right here, that's fine. Put in the trash. Make sure your name's on it. Make sure your name is on it. You need to do this before you leave today. There's only 2 questions. We still have time.
What if we're late because of this?
Huh?
What if we're late because of this?
Yeah, okay.
You better not.
Why is this game so easy?
Game?
Oh, shoot. I didn't do it.
Problems and that's why they call Victory Royale.